The topic is bus converter. The bus converter or elevator is a DC to DC converter that obtains a higher continuous voltage at its output than at its input. It is a type of switching power supply that contains at least two semiconductor switches, diode and transistor, and at least an element for storing energy, capacitor, coil, or combination of both. Frequently, filters constructed with inductor and capacitors are added to improve performance.
The bus regulator takes a DC input voltage and produces a DC output voltage that is higher in value than the input, but of the same polarity,
showing the path of current flow during the switch on and off time.
Whenever the switch is on, the input voltage is forced across the inductor, which causes the current through it to increase ramp up. When the switch is off, the decreasing inductor current forces the switch end of the inductor to swing positive. This forward bias the diodes are logging the capacitor to check up to a voltage that is higher than the input voltage. During a steady state operation, the inductor current flows into both the output capacitor and the load during the switch off time. When the switch is on, the load current is supplied only by the capacitor.
The next topic is the buck booster inverting regulator. The buck booster or inverting regulator takes a DC input voltage and produces a DC output voltage that is opposite in polarity of the input. The negative voltage can be either larger or smaller in magnitude than the input voltage. Buck-booster inverting regulator. When this switch is on, the input voltage is forced across the inductor, causing an increasing current flow through it. During the on time, the discharge of the output capacitor is the only source of load current. This requires that the charge loss from the output capacitor during the on time be replenished during the off time. When the switch turns off, the decreasing current flow in the inductor causes the voltage and the diode end to swing negative. This action turns on the diode, allowing the current in the inductor to supply by the output capacitor on the load.
Some applications that use boost converters are hybrid vehicles, for example the Toyota Prius and lighting system. This allows me to energize several electrical implements that the customer wants.